All right, guys, in this video, we're going to be looking at equilibrium constant and a reaction quotient topic. We have a multiple choice and a short answer question. So in this multiple choice question, we've got a reaction. Hydrogen plus iodine will make two hydrogen iodide molecules, and we have the equilibrium constant as 100. We have equimolar amounts of H2 and I2 are pumped into a previously evacuated rigid 1 liter container and allowed to attain equilibrium shown above at a constant temperature. If 0.6 moles of HI is present at equilibrium, how many moles of H2 were initially added to the container? Okay, so there's a lot of information here, and you got to break it down. Okay, what am I looking for? What am I starting with? What are the information I do have? So we're looking for, we had a container, and there's some H2 molecules and I2 molecules, and there were equal amounts of them, and they were put in this container. After the reaction settled, then there were three types of molecules. There was HI, there was I2, and H2, and they were at equilibrium. What we want to know is how much H2 was put into the container. Okay, so first thing I'm going to do is I am going to figure out how much I2 is in there, or H2 and I2 is in there at equilibrium. And I do that with the equilibrium expression, so that's going to be Kp is equal to Hi squared, because there's this 2 right here, over H2, oh, and these are all gases, so I shouldn't put them in brackets, that's my bad. So that's Hi squared over H2 over I2. Okay, just a little formatting. And then I'm going to plug in the numbers that I know. I know that Kp is 100. I get that from here. 100. And that's equal to 0.6 squared. And the reason why it's 0.6 squared is that comes from right here. Really, that's the moles, but since it's a 1 liter container, the molarity or the concentration of a B will be 0.6 molarity. So I can just put it as 1.16. And then I'm going to put H2 and I2 on the bottom. I don't know what those are, but essentially that becomes my missing variable that I don't know. So I'm just going to put x squared, because that's what I'm looking for. Okay, I'm just put placeholding x just to make it a little simpler, something we've all familiar with, to solve for it. Okay, now we got to solve for x. Quick little trick. If anything is on the bottom and anything is onto the side, you can just flip them. So that becomes 0.6 squared over 100. Okay. If you do that, x squared is going to equal 0.0036. So you're just going to have to plug that in your calculator. 0.6 squared divided by 100, you get 0.0036. And then in order to solve for x, we need to take the square root. Okay, so then x becomes 0.06. All right, so be very careful. A lot of students will see this and see this answer choice, and they think that's the right answer. That's not. That's just how much H2 we have in the container at equilibrium. We don't know how much there was at the beginning because we just know how much was at equilibrium. Now, how do we find out the rest of it? So we know there's at least 0.06, so A's wrong. But we got to figure out, we know it's B, not B, because there's more than 0.06 that it started with. So it's between C and D. So at least if you were right here and you logically think it out, you're 50-50. So how do we figure out the rest of it? Well, that comes from how much was made. And this is stoichiometry. So if 0.06 moles, or sorry, 0.6 moles were made, that means for every 2 moles, we had 1 mole of oxygen. So I should write 2 moles of HI. We have 1 mole of H2. So that's 0.3 moles of H2. So what I just did there is I figured out, well, if there's 0.6 moles of HI at equilibrium and there was none at the very beginning, those moles came from something. It came from the H2 and the I2. In fact, 0.3 moles of H2 and 0.3 moles of I2 went to make 0.6 moles of HI. So I started with 0.3 moles plus the remaining 0.06 moles that are equilibrium. So my answer is adding those up, and we get 0.36 moles. Right there. So C is the right answer. So we took the amount that all converted into the product of 0.6 moles, and we added it to the remaining at equilibrium. So our total is 0.36 moles that were added to the container. Okay, this one a little more simple, and it's a short answer question. I expect to see one probably on the AP test just like this. AlCl3 is known to dimerize reversibly in the gas phase. The dimerization equilibrium is represented by the equation below. Write the expression for the equilibrium constant Kp for this reaction. Okay, if it says we want the expression, this is how you want it to look. You go Kp, and we're dealing with gases here, so that's why we're using Kp, and that's going to be the products, so the pressure of Al2 Cl6 over the pressure of AlCl3, and that has to be squared because there's a 2 right here. And this is all you have to write. So for pressures, make sure it's in parentheses. Make sure you include your pressure points, the molecule that you're looking at, and then making sure it's squared or cubed or whatever it needs to be for that. So this is what you want it to end up looking like right here.